Hi, let's talk about multi-container pods. So in the previous video where I talked about the Kubernetes architecture, I also mentioned that in a single pod, in most cases we have one container running. But in some cases we can also have one container and along with it multiple helper containers, one or multiple helper containers. So that's what we'll talk about. Multi-container pods, as the name suggests, this concept is about having multiple containers in a single pod. The reason could be for initialization tasks, for setting up environments, or for monitoring, logging, etc. So let us look at what containers are possible inside a pod. So firstly, we would have these regular containers. These are basically the actual containers that we have worked with before this. So these are the applications that we have containerized. So any application that you containerize and that is the main container of your pod is the regular container. Then we have init containers. So init containers, these containers run during the time of pod initialization. So these containers should be completed before the main container starts. If init container is not completed, if it fails, then the initialization of the pod would not happen and the main container would not start. Only after this is completed, the main container starts. So these are basically used for setting up environment for the main containers or for initialization tasks. Then we have other containers like sidecar containers, ambassador containers. So with init containers, actually, these have a different keyword for the YAML manifests. So in the YAML manifest or in our configuration files, we mention them by init containers. But all these other we'll talk about sidecar containers or ambassador containers, all these are actually normal containers only. But due to their roles and responsibilities, we would call them like sidecar or ambassador, etc. So if a container is providing support functionalities for the main container, like logging and monitoring, etc., it would be called a sidecar container. Example is fluentd. Or if a container is acting as a proxy between the main container and the external services, then it would be called as ambassador container. Similarly, there is adapter containers. So they basically transform the data or they mediate the communication that happens between the main container and the external services. Basically, if our main container is sending data in form of JSON and we would want to convert it to YAML for external services, then we would use adapter containers. So these are the five types of containers: regular containers, and there are these helper containers. So I am at my Ubuntu terminal, and what we are going to do is we are going to create this multi-container pod, and in that we will have one init container, and that init container will keep on running until one particular service is up at a particular port, and after that the main container starts working, and that main container would be an nginx image. So let us create the configuration file for that. Also, if you are somebody who forgets how to write these configuration files or get confused about it, about these keywords and all, about how to write it, so you can use this tip. You can remember this mnemonic basically, AKMS. So whenever you start writing these configuration files, in most of these cases, like for pods, deployments, etc., you can use AKMS. So A stands for API version. This will ensure that you are not making any mistakes, because sometimes we may be putting one keyword inside the place where it should not be. So for that, this is really helpful. Version 1 would be the API version. If it is different, then maybe we'll look into it later. Kind would be a pod. Metadata would include name of the pod, which would be, let us say, my pod, sorry. And then we would have labels. Let us give some random labels. S stands for spec, and inside spec we have this containers. So this is how it looks. You can remember it through AKMS. Now let's write the containers here. This usually includes the list of containers, but what we will do is we will first define init containers. So in the spec, we will have init containers. Yes. And init container would have a name. The name would be, let us say, my pod init, and then it would have a image, and it has an image, and then it will perform, when it starts running, it will perform a command. So now this command basically is a list of commands that we can give to the busy box. So what we will say is we will say sh, and we would want to run a particular command into sh. For that we use hyphen c. Hyphen c basically means that whatever command we are going to write next, this should be double quotes, whatever command we are going to write next is actually a string. So hyphen c basically means whatever string I type here, write that as a command into sh. So what we will do is, let us say if I say echo waiting, this basically means it will print waiting, because this hyphen c is saying that whatever string we add here should be added as a command to sh. So that's how it works. Maybe we'll use it in a different way. Let us say there's another way of writing it. Let us say it's a list. So we will say sh, and then the second one would be hyphen c. Because it is a list, we can write it in that way as well, and we can write it in this way as well. And then we would want to write this string of commands. So let us say we would echo, we'll say waiting for the service my svc to be running, and we will now basically look that if the service is running or not. We will say until lookup, and we are calling it my svc, that this svc should be present in the default namespace, and after that this should be an svc, and it should be the part of cluster, and then local. So this basically is a fully qualified domain name. So how this works is the image, the object name, the namespace, then object type, cluster, and local. So now we have said that we are looking up for this particular thing to be running. If this is not running, until this runs, we would want to do a particular thing. Do, let us say we will echo again. We will say my svc not available, and we will say it sleeps for 5 seconds. And once it is done, then we would say that finally the service is up. We'll do proper indentation. Oh, sorry, until should be here. And then until this happens, we are sleeping it for 5 seconds, and then done, and then echo. I think it is correct. So this is how we will write the init container image. And now let's write for the containers. So containers we would want to run is, first is name. Name, let's call it Nginx only. Image would be Nginx. And let's say ports, container port. Let's keep it as 80. I think it is created now. I think it is correct. So if there are any issues, we'll look on it later. Let us try applying it. There is an error. It says error converting YAML to JSON. Did not find expected dash indicator. So let us get into the YAML. The error is at line number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Name, and then we have image. Okay, so indentation is not correct. Let us go to, let us go here. 1, 2, 3, 4. I think now it should be correct. 5, 6. Now it says pod in version v1 cannot be handled as pod. Cannot unmarshal object into go struct. Field contains container dot ports of type v1 dot container ports. I'm not sure. Let me check. The ports is a list, so we haven't added the hyphen here. Now it should be correct. It's still wrong. What is wrong here now? Cannot unmarshal string into go struct field pod spec init containers. There is something, some issue with init containers as well. We have a command. Okay, very clearly we have a mistake here. These are not properly intended. It's a list. It's inside the error command. Now is it correct? Let me first check. We have API version, kind, metadata. This is perfectly fine. Init containers is a list. This is again wrong. This is terrible. And then inside command, this should be a list. So this is how it should be. This is how it is. And then init containers and containers would be at same level. Then at containers, we would have this thing. Image is also wrong. IMAGE. We would have ports, and then ports would be at this level. I think now it should work. Finally, it works after ages of debugging. So let's say kubectl get ports, and we have it. So firstly, it is not ready yet. Out of 0 pods are ready, so the pod is not ready, and it says that status is init. So basically it was not running. Let us now see what's happening. The name of pod was my pod. Here we can see that the my pod init container is created first and started, but nothing happened after that. Basically our main container is not up and running. If you look at these things, you will see that it is not initialized yet, it is not ready yet, but the pod are ready to start the containers. The state is waiting, and the reason is the pod initialization is not completed. So until the init container is not completed, the pod initialization will not be completed, and it is not ready. This is the command that we have given it. And yes, so let us look at the logs for this pod. My pod. So maybe we have to say, we have to specify container as well. It was called my pod init. Let me also tell you what I did. So with this command, basically we are saying that in the my pod, go inside this particular container. So dash c is or hyphen c is used to specify the container inside that pod. So we went to the my pod init container. So we can see that here we have the echo command that the server can't find this particular image. We said that my service is not available, retrying, my service is not available, retrying, and it keeps on saying that my service is not available, my service not available, retrying. So now what we will do is we will create this service and then see if it starts working or not, or we can try doing exec into the nginx pod. So we will do exec. I don't remember the command, so I'll try to find it. Exec into pod. Pod, the name of pod would be my pod. Container is nginx. Is there a flag that I should do? Yes, I should sh. I think it should work. It says that container not found. So the nginx container is not found yet because it is not running yet. So now let's try creating the service. For that, what we will do is we'll use the expose command, or you can use it, you can create it using the configuration file as well. I'll use the expose command. kubectl expose, type name. So kubectl expose pod slash my pod. The port would be 80. Let us say target port, let's call it 80. Type, let's call it node port. What else do we have? Let us try, let us see if it works. The service has been exposed. Now if we try to do kubectl, okay, I did a mistake. So it was checking up for a service that was of name my svc. So we have to create a service with this particular name. Let us check the name of the service I created. It is of the name my pod. It won't work. So let me delete this. My pod. Now let me create the service again, but we have to specify name. I'm assuming that the name is specified using dash hyphen hyphen name flag. Let's call it my svc, and now it works. So we have our my svc service created. So now if we say kubectl get pods, we will see that now our pod is also up and running. Earlier it was not ready and the status was init. Now it is ready and it is running. So if we now see the logs for, okay, why I'm saying for. So if we see logs for the my pod, and inside that we want to specify the container, which was, what was it called? I forgot the name now. I forgot the name of that pod. So let us say describe pod, my pod. It's called my pod init. So now let me do it again. Get, we were using logs. So kubectl logs my pod. Inside that we want to go inside this container. It is not loads, it's logs. And we got the logs. So earlier we were getting this, that my service is not available, retrying, my service is not available, retrying. And finally, once we created that service, so it says that the service is up. And now earlier we tried doing sh into the nginx container, it was not working. Now let us try it again. Let me find that command. Yes, so we were trying to do sh inside the nginx container of my pod. We are going inside the my pod and we are going inside this container. Okay, maybe I forgot this interactive terminal flag here. And finally, we are inside this nginx container. So finally it works. Let me also try to see if it's running. For that, I'll say kubectl get svc because I want the cluster IP. So where is my image? This is my image I created. Sorry, this is my service I created. I'll copy this and I also have this port. So now when I do exec into the nginx container, I'll say curl and I'll say the port number is 31360, or maybe I could do, and we would go to the port 80 and it works. I made the mistake there. So finally we get the response from the nginx container and the nginx container is up and running. So this is basically how the multi-container pods run. We saw that it was not running before we started that particular service, and as soon as that service was available, the main container of the pod started running and the pod came into the running status. So that is how the multi-container pods work and how they are created. So thank you for watching this video and I will see you in the next one.